All right, so we have this square pyramid, and it's got a perpendicular height equal to the side length of its base. So if I make that x, this height is also x. And show that the angle between the slant edge and base edge. So it's really talking about the slant edge. So for example, let's go over to this corner and the base edge here. So this angle here. So it kind of looks like this. In order to do that, actually, because it goes up to the middle here, let's drop a perpendicular down there. This point, so this is the, let's call it A. Let's call this B. Oops, no, it doesn't fit on there. So that's B. Let's call, so the point here, if that's A, that B. This would be, let's say, C, but C is right in the middle here because that's dropping down to make it a right angle triangle here. Okay, that's what we're looking for. But of course, in order to find that, we need to, and we know, for example, that side length here is x. So this must be half x. Let's make that x on 2. And we know, what else do we know? We know that, okay, we don't know BC. But if we look at that as a triangle here, it's a bit hard to see, but that will be the height. And then it's come out like this to C. And then that is halfway from here to here. So again, that distance there is half x, or x on 2 as well. So then we can find this B to C distance, which we need here in order to find our theta. So let's find BC here first using Pythag. Sorry for my drawing. So we've got that BC squared is x squared plus x squared on 4. This is like 4 on 4. So we are getting 5x squared on 4. And if we square root that, we get square root 5x on 2. So that's what that equals. So now if I do tan of theta, I've got the old opposite over adjacent. So I'm dividing by x on 2, opposite over adjacent. So that means I'm timesing by 2 on x, same thing. 2's cancel. X's cancel. You can see we just got root 5, so theta must be the inverse tan of root 5.